Guys, welcome back. So in this lecture we are gonna see the various inputs that can be applied to a system. So now let's see the first one, which is the impulse input. Now what is an impulse input? In impulse input, first of all it is represented by delta t, and in input the condition is delta t will be equal to 1. This is the origin. This will be equal to 1 if t is equal to 0. If the t is equal to 0, that time only the delta t will be equal to 1, else it will be 0 for t not equal to 0. That means for any other value of t, the impulse input value will be 0. So this was the impulse input. Now let's see the step input. Now what happens in a step input? The step input is represented by ut. The step input is represented by ut, and the condition for this is it will be equal to a. Here it is given a, so I am writing a when t is greater than or equal to 0. That means the step input will always be positive. For time less than or equal to 0, that means the value of step input will always be positive, and it will be 0 for the negative values. So this was the condition for step input. Now let's write the Laplace, cause you will need the Laplace values of these inputs. So Laplace of the impulse input, here it is 1, so Laplace will be equal to 1. Now in step input, the step input answer will be equal to a, so we can write the Laplace of the step input equal to a. A is a constant over here, so its Laplace will be a by s. Okay, now let's see the other two inputs that can be applied. Here are the other two inputs. The first one is the ramp input. Now what happens in a ramp input? Ramp input is an increasing function or an increasing input. So we can write rt, and here you can see this is the slope. So we can write it as a t. That means the formula for slope, y is equals to mx plus c for time. That means for representing it in terms of time, we can write it as at for t greater than or equal to 0, and it will be equal to 0 for t less than equal to 0. That means even the ramp input will be applied, and it will be positive for all the values. The ramp and the unit input can never be negative, they will always be positive. And now when you will substitute a is equals to 1, if you substitute a is equals to 1, it is called as unit ramp. When you substitute a is equals to 1, it will be called as unit ramp, and it's so the value of rt will be equal to t. The value of rt will be equal to t for this unit ramp. And now we can find the Laplace as well. So Laplace of rt, here it is a t, so its Laplace will be a by s square. And if you will apply the unit ramp, that means if you will apply a is equals to 1, that time for unit ramp the Laplace will be 1 by s square. Okay, so this was for the ramp input. Now let's see the parabolic input. Now what happens in a parabolic input? It is an increasing input. Now to understand parabolic input, you can take it as rate of change of velocity is acceleration. Rate of change of velocity is acceleration, that we all know, and that acceleration is the parabolic input. So for the condition for the parabolic input will be, it will be, this is a bit different from the other, a by 2 t square for t greater than equal to 0, and it will be equal to 0 for t less than equal to 0. That means it is a positive increasing value, and the value of the parabolic input will be a by 2 t square. And now even you can write here as unit parabola, like we have done here unit ramp. Even here you can write it unit parabola, and unit parabola means substituting the value of a. So if you substitute the value of a, the value of will be t square by 2. This will be the value for unit parabola. Now let's find the Laplace for parabolic input. So, and even this parabolic input is represented by RT, and even ramp input is represented by RT. This you have to keep it in mind. And now let's find the a by 2 t square. So its Laplace will be a by s cube. This will be the Laplace for the parabolic input. And now if you are applying a unit parabola, so the answer will be, the answer for the unit parabola will be, we will substitute here 1, so it will be 1 by s cube. These conditions which we have done over here, these condition for the impulse response, that it is equal to 1 at which time, and these conditions for all the four must be known to you before we solve the further sums. And this is just a basic for solving your other sums related to the steady response and transient response. So if you have liked the video, you may subscribe to the channel, or else you may give a thumbs up. So until then, bye.